Okay, let's check our work. Turns out that of the 11 statements in the previous podcast, all of them were true except for number 6 and number 11. The results are here on this page. You can check. Why is number 6 false? Number 6 says the log of 9 to the base 3 equals 3. Well, that means this 3 to this third power equals 9, which is false because we know that 3 to the third power is 27 instead of 9. So it's not true that the logarithm of 9 to the base 3 is 3. Instead, the logarithm of 9 to the base 3 is 2, since 3 squared is 9. The other false statement is number 11. The logarithm of negative 27 to the base 3 equal negative 3. Well, according to the definition of logarithms, this would mean that 3 to the negative 3 is negative 27. But we know that's false, since 3 to the negative 3 is 1 over 3 cubed. Remember, negative exponent means take the reciprocal and use the positive exponent. And 1 over 3 cubed is 1 over 27, not a negative 3. In fact, the logarithm of negative 27 to the base 3 is undefined. It doesn't have a value. It has not been defined because if we say logarithm base 3 of negative 27 equals a for answer, this means 3 to the a power equal negative 27. Now we have to think, what exponent goes on 3 to give us a negative 27? Well, if we look at the graph of y equals 3 to the x, it looks like this. It's an exponential growth function. This is the graph of y equals 3 to the x. 3 to the 0 is 1. 3 squared is 9. 3 cubed is 27. 3 to the negative 1 is 1/3. 3 to the negative 2 is 1/9. 3 to the negative 3 is 1/27. This graph never touches the x-axis, and it never goes below the x-axis. So what exponent goes on 3 to give you negative 27? There's not one. A negative exponent would mean take the reciprocal. So you can never take the logarithm of a negative number. The domain of a log function is always positive. You just can't take the logarithm of a negative number. So when I see this log of negative 27, I know that whatever statement I have there is false unless it says that's undefined.